Bismillah ar-Rahman ar-Rahim. Student, this is a paper, October 2023, 41 variant, complete mechanics paper. So let's start. Question number 1, a particle of mass 1.6. Best way of doing the paper, read and write. Projected, what this means, whenever you throw something, after leaving from your hand, the applied force becomes 0. So it means there's no applied force because you threw the particle. That is called projected. Speed of 20, so starting velocity is 20. Okay, and smooth inclined plane, so friction is actually 0, and tan alpha is given by him. So I think data is very, very clear. And what is asking for energy method and find distance of the particle, move the plane becoming to finally at rest. So it means last velocity 100% 0. Okay. So let's have a plan how we can do it. So first of all, this state tan given, and I think we need, okay. So what is the tan? Opposite by adjacent is x. I can use Pythagoras theorem, x square, hypotenuse square, opposite square plus adjacent square. Take a root of whole, I get a 5. From here, I can get sine alpha because friction is 0, so cos alpha not required. Only need sine alpha. And sine alpha is what? Opposite by hypotenuse. So 3/5. So this is sine alpha, I need it. You can take a tan inverse and then take that sine of that value after taking inverse is also correct. So let's go for the diagram. So according to situation, it is thrown up. Okay, and finally it will stop on the peak on the top. All right, and this is as assume. Okay, this is a distance from here. Wait a minute, from here till here. I assume this s distance, or I take x better. Okay, or d is also okay. Distance d, and there's a height. There's a b for bottom, t for top. And particles starting from here, and ultimately it stops here. Last velocity is 0, and starting velocity is 20. Okay, and it's traveling upwards. So I will apply the magic formula. So we need for that reason, and for your knowledge, because friction force is 0, so work done by friction force is 0 because this F times to distance, force into distance. But as force is 0, so this is confirmed 0. And as applied force not there, so work done by applied force also 0 because this F into D. If F is 0, this also 0. So I believe this part is also clear. So magic formula is actually work done by applied force, work done by friction force, kinetic energy plus potential energy at end point, because traveling from here and reaching on top. So I write T for top because always ending point. N minus kinetic energy plus the starting point. Starting point is B, B for bottom. Because this is both values are zeros. So this is 0 and this is 0, both gone. Or I show you what I'm saying. I'm saying this 0 and this 0. So kinetic energy, potential energy at the top and K at the bottom. So I bring this whole left side. So formula will convert. Actually, I've shown this whole working. If you want to skip it, and as you know, these two values are 0. So potential mechanical energy at the top is equal to mechanical energy at the bottom. So you can write directly even. So no need to show this whole working if you are familiar this way. Now, students, it means this formula, I given equation number 1. I need three things. Potential energy at bottom is 0 because height is 0. So let's try to find it. Or I can plug in it directly even here. What is kinetic energy at the bottom? Mass is 1.6 kilogram, half into mv square. V kinetic energy at a B is 20 speed, half mv square. And this is 0 because height is 0, you know, mgh, gravity, height is 0, that is why. Kinetic energy on the top, it means he said that it will coming to rest on the top. So this is also 0. No need to work for it. Now, interesting part, only one part. What is potential energy at the top here? MGH. And this H I need to find. So using this triangle, I will find it. How? Opposite by hypotenuse. I'm finding it here. Opposite by hypotenuse equal to sine theta. Opposite is unknown, distance is d, and theta is sine alpha. Actually, I should write here alpha, sine alpha. And sine alpha is 3/5. So height is turned to be 3/5 times 2 distance. Okay, now what is potential energy? MGH. Mass is 1.6, G is 10, height is this. So 3/5 times 2D. I think now, students, this is all okay, and let me drag it down. It's mixing up somehow. Okay, this part is clear. All right. Okay, now, student, just a matter of typing in calculator. And if I type in calculator, so first of 1.6 cancel, and this is a 400 by 2, 200, and here 30 by 5. Okay, and this 0, 0 cancel out, so 100 by 3. So this is turned to be 33.3 meters. And I believe you got my point. Question number 2. He's saying, question number 2, that mass is a 2.4. Okay, I'm reading and writing. Mass is 2.4. Okay. If you want to put a box like this and write M on top, is also a good way if you want to save your time. Okay, equilibrium. So, one of a mass attached, A. What is A? Mass 2.4. What is weight into 10? So 24 newtons acting downwards. Okay, here I have 2 ways to do it. Lami's rule I can apply. Lami's rule, I will show you both. Okay. And second technique, I have a resolving components. Okay. Tension, find a tension in each string, we have to find it. Let me tell you, if I have a ring here, so tension here and tension here are equals to each other, T and T. But if we have not a ring here, this is a bead or a mass, like here attached. So then tension in both particles are different. So T2, T1, or T1, T2. So no, you can take any order, no problem at all. So student, I will do this question just sake of your knowledge 2 ways. Okay. So let's start. So what is this components? We can see this is a component number 1 and component number 2 is a 40. So this angle is 40. And this turned to be 2 T2 cos 40. And this become T2 sine 40. Same way, this is going this way. So it has a 2 component, 1 this way and 1 this way. So 35 is here. So 35 is here. When angle given, that is cos component. So T1 cos 35. And here T1 sine 35. According to situation, students, it is a very clear that is the upward forces equal to downward forces due to the equilibrium, and right side force equal to left side force. So we have this technique applicable. So, so let's try to solve it. I can say these 2 forces equal to this one. So I'm writing T1 sine 35 plus T2 sine 40 equal to 24, equation number 1. And this part left and right equals to each other. So T1 cos 35 equal to T2 cos 40. So if I bring it down, students, so it will turn to be T1 subject and cos 40 by cos 35. Let me check it and what I get. So cos 40 divided by cos 35. I'm getting here 0.9352. At least 4 to 5 dPs is good to write. Equation number 2. So this value of T1, I'm going to plug in it here. Put in 1. So when I plug in this whole thing here, so sine 35 will multiply. I'm writing 0.9352 times to T2 times to sine 35. And this as it is. So T2 sine 40 equals to 24. So what is common from here? T2 common out. If I take T2 common out, students, what in bracket left? 0.9352 into sine 35 plus sine 40 and equal to 24. I'm saving you time. The whole thing will divide under 24 and I get T2 what? Let me type it all together. T2. So in fraction 24 divided by 0.9352 into sine 35 plus sine 40. And my answer is coming with me 20.3528. After rounding, T2 becomes 20.4 newtons. I believe you got idea. So this value, I'm going to put it there, but don't put rounded one, put without round. So when I plug in this, put in 1, what I get, students? So I get T1 is equal to what? I just plug in directly there, multiply, and times 2.9352. My answer is coming to 19.033. So after rounding, T1 is coming 19.0 Newton or 19 Newton, so no problem at all. This is method number 1. I can teach you method number 2 as well. Okay, so this is available. Method number 2. So this, I'm just showing this B, A, and 2.4. So look at here. This is, I believe, inshallah, you will feel easy with this method even. Lami's rule applicable in 2 situations. 3 forces acting in equilibrium. So it is acting. First force is tension 2, here tension 2, here tension 1. This is what? 24 newtons. Now, interesting part, you need to find angles all. So this is what? 40, and what is this? 90 degree, 90. So if you check it, 90 plus 40 is 130. So this is 130. Same way, what is this? 35 and 90. So 35 plus 90 becoming 125. And last left, and what is this? You can subtract from 360. I think it's very clear, and it's 105. Or from 180, subtract 40 and 35, it is same. So I believe this is part is very clear. Now, what is Lami's rule? Just like a sine rule. Okay, like if I this one, so this is force keeping up divided by sine of this equals to this, keep it up by sine of this over. It will cross multiply and we get a T1. Mabruk. So you see 24 times to sine 30 and you check it in calculator. If you type this in calculator, you get a T1. Okay, and I just drag slightly left side because I need to work for second part. And T1 is coming, you can check 19 newtons directly without any working. Now, same way I can work T2. T2 up and sine of 125 down. So it's look. And this up and this down. Over. This will multiply there and you will get your answer. So 24 times to sine 125 over sine 105. And if you type this in calculator, it will give you 20.4 for sure. So I believe you got a second method is OR. It's called Lami's rule. I just tell you what is this is called Lami's rule. L-A-M-I rule. Lami's rule, and this implement in 2 conditions, 3 forces and equilibrium. Otherwise, we can't apply. So let's go for next question. Number 3. Question number 3 is what he said that diagram values are mentioned. So I'm not going to read it. But best habit, make you read it properly. Okay. Sometime we give an extra thing here. And I think some values are not, so I have to read better. In 8 seconds is 12.6. Okay, done. But maintain this speed for 40 seconds. You can see there's a maintain speeding. Okay. And then it decelerates for the 2 stages. Stage number 1, stage number 2. So it's between 48 to 62, stage number 1. it decelerates by A. So this is decelerating by A. Okay. And between this and this is 2A, double speed, you can say 2A, double acceleration, sorry, deceleration, and come to rest. So distance covered by the bus in first 8 seconds. So 8 seconds means this triangle he talk about. So what is distance traveled in the first one? You know, the area, half into base into height. Base 8, height 12.6. And if we check in calculator, this answer turned to be 50.4 meters. And I believe the point is clear. Now you talk about for 3 marks, find acceleration, A. So best technique, let me write all coordinates. This coordinate, this coordinate, X is 48 by 12.6. So 48, comma 12.6. Make sure first X value and then Y value. Don't make the wrong order. What about this? 62. So this point is X62, but Y I don't know. I will assume V1. Because this velocity I don't know, I assume V1. And this last ending, where is particle going to stop? So this is a very simple, time is 70 and velocity 100% zero. So students, I think so we can get it easily if we apply two gradient formula, because you know that two rules are there. Rule number one, area under lines is actually equal to distance. And gradient of the line is actually acceleration or deceleration, same thing. So I'm going to find this gradient first of all. So let me find first here, then I bring it down. So what is a gradient here? You can find an acceleration, A. Okay, first let me write M, gradient, y2 minus y1 over x2 minus x1. Gradient is A, and y2 is v1, y1 is 12.6, x2 is 62 and 48, x1, x2. So 62 minus 48. This is a value of A. The same story I apply here. We're going to apply here. So gradient is equal to same formula, y2 minus y1, x2 minus x1. Gradient is 2A, and y2 is 0, y1 is this. I can write any order. I can start from here even. So v1 minus 0, like this, minus this, or this, minus this. No issue. But keep the same order. So I think this, okay. Now I take this both equations, cut from here, I bring it here down. This one thing. And same way, I'll go up and bring the second part down. Okay. And I paste here. So two things, I got it. So let's start up. And you can see this one. This is value of A. I'm going to plug in it here. So 2 times 2A value over V1 by, and this is coming -8. And this is what, student? This is this is same, I'm copying here. V1 minus 12.6 by the gap. And gap is very clear. So 62 minus 48. It is coming 14. So this is a 14. Now I can work on and get V1. And what he was asking to get at the acceleration value, okay? So this is a cancel, 2 7s are 14. So V1 minus 12.6 over 7 and V1 over -8. Cross multiply. I am doing it here. So V1, -8 V1 and plus, so 12.6 times 2, 8. And I get what, students? Negative, positive 100.8 and 7 V1. So 8 will go there. I get a 15 V1 and 100.8. So 100.8 divided by 15, I get a velocity. V1 is coming with me is 6.72. And this value, if I plug in it any one equation like here or here, I think plugging it here, I get my answer. Okay. And hold on. This is a some space problem. I drag it slightly up. Now I can do it easily. So I plug in this equation. So acceleration equal to 6.72 minus 12.6 divided by 14. So this and divided by 14, and answer is coming with us negative 0.42 meter per second square. But he asking this A stand for deceleration. You see, deceleration. So itself it's negative sign. So what is final answer? So deceleration is actually is coming with a 0.42. Or you can say A value is 0.42. And I believe the point is very, very clear. Okay. So I have to eliminate the minus sign. And because he represents deceleration A. So you write deceleration word or you write small a letter. This is my final answer. Some students can say that you got a negative answer A. So why you eliminate? Because A is actually deceleration. That is why I eliminate. So that's done. Let's go for next part. Average speed of the bus for the whole journey. So it means, students, I need distance 1. This is distance 1. This is distance 2. This is distance 3. This is distance 4. And all distances I will add divided by total time, which is 70. So first distance, luckily we have it. No need to work out. This is rectangle shape. And it's very clear. This is 48 minus 8. So it's a 40 gap. And the height is for 12.6. So length into width. But this is a trapezium shape and this is a triangle shape. I will find both. So let's work out here. So I can work out here, then I shift it back. Okay. So let's start. So distance total traveling is what, students? So this is, I'm not working out, I'm writing the answer directly, 50.4 plus. What about D2? 40 times to that. 40 times to 12.6 plus. What about trapezium? For your knowledge, this is this and this are parallel to each other. So this is called A, this is called B. Whenever you know trapezium formula, you apply. You must know, and this is called gap between, it's called height. So look at now here, I'm going to apply half and height. Height is 62 minus 40. So it is, so 62 minus 48 is coming 14. And A is this height, B is this height. A is this height is V1, which is just, I got it, 6.72. So this is a V1. Look at, I show again, trapezium shape is like this. This is called A, this is called B, and this is called H. And A is, I just got 6.72. 6.72, correct. And this is, what is height? This is B, is 12.6. Plus, now talk about the last triangle. So triangle, hold on. It's creating some issue of space. Okay. Half into base into height. Half into base is what? 70 minus 2. This is gap, how much? 8. And height is this, is, 6.72. 72 over. So what I will do, students, this whole line, I will take from here, cut from here, and paste on this one. Okay, so this is very clear distance. And if I calculate, so distance, total distance is coming with us. If you calculate all and I'm just saving your time, students, this distance is coming 716.52 meters. And now what is average speed formula? Total distance by total time. And time is 70. And if you check it in answer calculator, answer is coming 10.2 meter per second. 70 is, if you see this, this is 70. I hope so point is clear. And let's go for next question. He's saying two particles P and Q. P mass is 6. Q mass is 2. Be careful. It should not mix up. Okay. And lie at rest What is the gap? 12.5 apart. And the coefficient of friction between the surface and the particles are 0.4. And P is thrown, projected. It means thrown. After thrown, applied force gone. And we get a speed of 20. So Q has a speed of 20. Show that speed of P immediately before collision with Q is this much. So show that speed of P. Okay. So make sure P is thrown toward Q. So I just show you the concept. This is a P particle. P particle in mass is 6 kilogram. And throw towards the smaller particle is 2 kilogram and particle is Q. So it is thrown and the gap between them is very, very clear. That is our 12.5 meters distance. Okay, launching speed is what? 20. So U is equals to 20. And the mu is given by him is 0.4. It is very clear. We have to find out the speed at it reached the Q. So what is the final velocity of the P particle just before hitting Q? And we have to show this answer. Okay, if you see the data, we have U20. We have distance S is 12.5. Okay, right, D or S, no issue. And I need to find out the QV, but acceleration I don't have. Okay, I can apply the formula. So for the acceleration, let's talk about P particle. P particle 6 kilogram is going right hand side. Applied force, backwards, friction force. Basic formula, net force equal to ma. Applied force minus friction force equals to ma. But as you know, it is a projected. So applied force is 0. So 0 minus friction. What's friction formula? Mu r. And mass of this 6 kilogram. So what is the R? R is, if you see carefully, let me drag this down slightly. When it's placed on the earth or a surface, its mass, its weight acting downwards and R acting upwards. And this is 6 into 10, 60 newtons. So mu R, mu is what? 0.4. R is what? Equals to 60. Let me check. Yes, 60 and equal to 6a. So if we check it, it's coming -4 meter per second square. So Alhamdulillah Rabbil Alameen, I got acceleration, and this -4 I will utilize now. So you see, students, how I got this answer. I hope so you got my point. 2as is equals to v square minus u square. I showed extra working. If you are expert enough, you can save your time. Just for sake of your understanding, I'm showing full complete working. Anyway, last velocity question mark, U is 20. So, acceleration value you have to plug in, and that is a -4. So this is 200, 220 square is 400. It will go there and add. So 400 minus 8 times 2, 12.5 equals to v square. Take a root of the whole like this. And now I'm typing in calculator and let me check. Yes, it is coming same answer, which is 10√3 proved. Meter per second proved. So I believe you got the point. Let's talk about the next part. In the collision P and Q coalesce, then when the particle make a R, they just make it here before collision and after collision. This is before collision. This is after collision. Okay, before collision, you know it very well. Situation is 6 is going towards 2. There's a P particle, there's a Q particle, there's a 6, there's a 2. Okay, let me copy. And this before collision, and here after collision. Okay, students, this is after collision. And after collision, what is going on? This particle will behave as a together one particle. And this will deal as a not a PQ, this will deal as a R. They will behave as a one particle, and we will take this as a R. Okay, now P is traveling towards Q, but this speed. So what is this speed? This U is, U1 is, let me say, let me check, 20, I think. Yeah, 20. And this U2 is 0. And speed of the hair collectively, one speed is there. So what is the formula? M1 U1 plus M2 U2 equal M1 V1. But here V speed same. M1, so VV common out. I'll get M1 plus M2. So I'll take common out. Okay. And I write what here? M1 plus M2 times 2V. So mass is 6, V is 20. So 6 times 220. This is 0. Here both masses add become 8. And speed I don't know. So speed I get what? 120 divided by 8. And yeah, wait a minute. Yeah, okay, 1 minute. I think this one mistake here. This is launching speed. When it's just before hitting, the speed is 10 root 3. So we have to take this speed is not that. This is 10 root 3. So 10 root 3. 10 root 3. Just before hitting. So 10 root 3. So now students, what I get? So 60 root 3 and divided by 8. And I get what? 15 divided by 2 root 3 meter per second. This is a velocity of our particle. Now what is asking? Loss in kinetic energy. I will find kinetic energy before collision, and then I will find kinetic energy after collision. And formula half mv square. Again, before collision is this. This is speed is 0, so there's no need to calculate. This mass and speed is given. Half into mv square. Mv square. V is v square and v is 10 root 3. Same story here, but here because both are together behaving as the same particle, half into mass becomes 6 plus 2, 8. And velocity, I just got it here. So this behaving as a velocity, 15 root 3 by 2 and square. I'm finding both. So this into 4, I got it 675 joules, the below one. Upper one is 3 times 2, 100 times 2, 3. It is giving us 900 joules. And if you subtract, the answer is coming finally. So loss, why loss? Before is more and after is lesser. So naturally loss of kinetic energy, just subtract them and we got 225 joules. No need to put minus sign because loss itself representing minus sign. So alhamdulillah, Rabbil Alameen, I believe the point is very, very clear. Now he said that coefficient of the friction between R and plane that already R mu value is given. Find distance traveled by Q, R particle become rest. It means final velocity 100% 0. And starting velocity of R, we have it just now, we got it. This is starting velocity of the R, and that is a 15 root 3 over 2. 15 root 3 over 2. Problem is that if you have acceleration, I can find distance easily. But same story, the way, remember student, this is the way we found it. This is technique to find out the acceleration. Same story I will apply here. But this time is R. R is what mass of R? 6 plus 2, 8. So this is our situation. This is a particle, 8 kilogram is applied force, is frictional force. Okay, this is R. This is into 10, we got 80 newtons. And net force equals to MA. Capital F minus small f equal to MA. Capital F is 0 because he threw the part. It's moving due to its inertia or potential. Friction force is mu R. Some students think friction force, you found it here, remains same. No, it depends upon the, because you know friction force mu R. It depending upon the R. Mass is what? 8. Acceleration I need to find. So this is what? 0.4. R is what? R is equal to 80. And this 8 will divide. So after this dividing, if you check in calculator, so 8, 10, and 10 becomes just -4. So acceleration becoming -4 meter per second squared. So I got it. Acceleration now I can find easily. 2as is equals to v square minus u square. So -4, s is my target. Last velocity is 0. U is 15 √3 divided by 2 squared. So this is the -8, and then when it divides there, okay, and I am typing in my calculator. So 1 minute, please. Divided by 2 square. This is coming with us -168.75, and divided by 4 2s are 8. And when I divide it by 8, my answer is coming with me 21.09375. So S become I need dot want. So add 21.1 meters. And I believe you got a point very, very clear. So let's go for next question, number 5. What a question we have. Read and write. Mass of the A particle is given here, which is mentioned in the diagram. Don't write. Save your time. And mass of the B particle given here. He's saying the particle are connected, okay. On the planes, okay. And string taut, okay. Okay, planes, and 2 particles are rough, which is very important information. Sometimes one rough and one, this is not 0, sometimes this is 0. So it depends upon the question. So we have to be careful. Both particles, both planes are rough. Okay, it has friction with the same coefficient of friction. So both, what is the mu here? Same mu here. Okay, so we have to find out what mu and limiting equilibrium. Limiting equilibrium means student acceleration is confirmed 0. So let's try to solve it. So job number 1, resolving forces. What is this mass? 1.6 into 10. 1.6 into 10. I got one jump here. It becomes 16. So this is a 16 newtons. It has 2 components, one acting parallel to surface, and one is, this is R, and what is inside. This is what? 16 sine 50. This 16 cos 50. Same story here, students. Wait a minute. Okay, this mass is 1.2 into 10, 12. 12 sine 40. And this is because this weight is 12 for sure. So this is R. And this is confirmed 12 cos 40. And tension 100% towards pulley. There's a rule, we know it very well. Okay, now we will see that where it will about to move, not moving at all. We know that, but about to move. 1.2, 1.6. Naturally, this is a heavy particle. So this will about to move this way. I'm writing the word about. And this about to move this way, I believe you got the point. About to move downward, friction backward. So this is a friction I mentioned up. About to move upward, friction 100% backwards. So I believe you understood these forces. If you will not make, it will be a big issue for you to solve it. Best idea, do all these forces mentioned first. Now I will apply net force equal ma plus a particle. So let's apply a particle. So net force is equals to ma. So net force, it is about to move where? Upward. So I start from here. So tension acting upward, friction downward, weight component downward. So T minus friction minus 12 sine 40 is equal to 0 because acceleration is 0. So this is my first part. But thing is that not over because friction is mu r. And r is what? R equal to 12 cos 40. And times 2 mu you write before after no problem, 10 for 40 times 2 or 12 mu you can write even 12 mu even 12 mu times 2 cos or mu times 2 no problem at all, mu times 2 12 cos 40 minus 12 sine 40 equals to 0. Equation 1 ready for the B particle. Because system is about to move downwards, so this is bigger force, this is a smaller, both are smaller. So this minus this equals to ma. So I'm writing here net force is equals to ma. Now weight component is 16 sine 50 minus two forces acting upward, tension and friction. So minus friction minus tension equals to 0 because acceleration 0. So 16 sine 50, friction is mu r, tension as it is 16 sine 50, mu is unknown, r is what? For this particle, r 16 cos 50. Okay, equation number 2 ready. So students, I can do it or do one thing. I think for the top equation or for the down equation, any one equation, if you shift, for example, if I think so better to do from here. Number 2, if I shift this tension on the right hand side, I'll get a T value. So this is full called T value, which I'm going to plug in it here. So put in 1. So when I plug in this T value there, so what happens, students? Or I think this is clear. There's this value I'm going to plug in it here. So I'm getting what? 16 sine 50 minus 16 mu times 2, 16 cos 50. Okay, this is coming from here. Now this whole thing I copy. So I just copy paste better. This is saving my time. Copy, you see, I paste here. And equals to 0. Equals to 0. Repeat. This value of going T is there. And the whole thing as it is here. Now, students, there are two mu values. This value and this value, I keep it here. These two values I bring on the other side. And I take mu common. So look the way. And this negative, because both are positive, but this value and this value will add. Now this whole value will divide this whole value and get a mu value. And I'm typing in calculator, student, just wait. Okay, 16, lot of temperament, patience required. Okay, 12 times to sine 40. And in denominator, 16 times to cos 50 and plus 12 times to cos 40. And my answer is coming with me 0.23326. And after rounding, I don't want. So 0.233 is our final answer. And I believe you got a point very clear. Okay, question number 6. He's saying a car mass is given. So I'm writing mass here. This is easy to focus. And moving on a straight road, not inclined. And a horizontal section of road, a car, constant speed. Constant speed, we know it very well, acceleration 100% 0. And constant force of the resistance, this is called friction force. So friction force is 650 newtons. And calculate a power developed by the car of engine of the car. Basic formula, as you know, net force is equals to ma, and applied force minus friction force equal to 0. Why? Because acceleration 0. And we have a formula, power equal to F into V. This is a formula. If I bring it down here, so I get a power by V equal to applied force. Applied force is here, so I can replace this here. And friction force I can bring on the other side. Power by V equal to friction, and this will multiply, and I will get a power. Force, friction force into velocity, friction force into velocity. So Alhamdulillah Rabbil Alameen, I believe this is nothing hard, and we got 19500 watt. But he said kilowatt. So divide by 1000, and 19.5 kilowatt is our final answer. So I hope so clear. Now he said that the power is suddenly increased by 9. By means adding. So power is first 19500 plus 9000 adding more. So when I add 19500 and plus 9000, so it is becoming 28500 watt. Okay. Now, student, what is the story? He said power is increased by this much. Find the acceleration of the car. So naturally, and because these both parts because part number 1 and part number 2 under the influence of this step, so we will take same velocity. So what is the basic formula? We'll do same net force equals to ma. So applied force minus friction force equals to ma, and force formula power by V minus friction equals to ma. Power formula, power value, we have 28500 divided by 30. Friction force, I think you know it, 650. And mass is how much? 1300. So now I'm going to plug in and type in calculator. Okay, divided by, so I got here 300. And divided by 1300, and I got a 3/13. And then answer is coming with the 0.231 meter per second square. I believe the point is clear. So what is the next part we have? On a section of the road, we have given this one. You know, if alpha equal to sine theta, sine, for example, I give you another idea what I'm saying. Sine alpha is equal to 0.08. If I bring sine on the other side, this become inverse of sine and 0.08. So you use this one, or you use in the place of sine alpha 0.08. So same thing. So I saw from here, and I taken equal to alpha, and I brought sine inverse left side. I got this value. So let's proceed. It means section is inclined, and friction and resistance to motion this time given this formula. So let's apply formula. First make a diagram. Okay, and the car is traveling downwards. Car is traveling downwards. And constant speed. So constant speed, acceleration 100% equals to 0. And the power engine is working by what? 11.5 kilowatt. So multiply in 2000, 11,1500 watt. Okay. It is a, you know, this is a force, applied force, and this is mg sine theta, weight component, and backwards a friction component, because system is moving downwards, motion is downwards. So this is applied force of engine, this is a weight component. Weight component is helping the applied force. So students, I can say net force equals to ma. If I apply capital F plus mg sine theta minus friction equals to mass into A. Applied force, we know it formula, a power equal to FV. F goes down, so power by F is power by V is equals to F. So this value I'm putting here. Okay, mass, I think we know it 1300. So 1300 and gravity 10, so 10, and sine theta or sine alpha, I will take 0.08. 0.08. Friction value is given by him is this. Sorry, this outside minus sign. And mass again 1300. And oh, sorry, this 0. Why 0? Because he said constant speed. Now, students, power I can plug in, and power is this much. 11500. Velocity speed is what? Is unknown. I'm leaving as it is. And this you type in calculator, 3 zeros with 13 into 0.08 is turned to be 1040. And minus 1000 and minus 20V equal to 0. So this is coming only 40. 40 goes there. I get a negative 40. And 11500 by V and minus 20V. So multiply by V in a whole equation. Into V here, this become 11500. Into V here, I get a 20V square. Into V here, I get a negative 40V. Bring all there. So 20V square minus 40V and negative 11500 is equal, okay, equal 0, already have it. So I think student up till here, okay. Writing 0 here or writing 0 there, no issue at all. Nothing change comes. Okay, I can apply quadratic formula. Okay, or you can divide, you can make it easy, or directly you can apply formula, and but writing at least one step. Negative B plus and minus B square for A C is this over 2A. As a teacher, I suggest you, oh sorry, 2A, not 20A, 2A. At least show this working step, and then you can do directly in calculator. We got two answers, 25 and negative 23. This ignore. Okay, this is my answer. And I believe you got the point. Let's go for question number 7, students. So question number 7, what it says? A particle moves straight line starting from O, okay, and moving and rest at a point X. It means starting from rest and ending, we can't say starting from rest. He says starting from O, okay. And becoming his rest, that is to confirm last velocity is 0. I mean, if I plug in here 0, I will get the time when it stops, okay. All right, we have 3 equations, 3 pattern of equations, okay. Now, I will show you diagram even, although he did not ask for us diagram, but diagram will help you more. And as a teacher, I suggest you learn the way how to sketch, because 9 marks depending upon proper understanding. 0 to 2, we have this velocity, 2 to 8, we have this velocity, and after 8, we have this velocity. And student, he said that at velocity 8, there's a no change in velocity. It means at 8, these two velocities are equals to each other. So I'm saying V equal to V at T equals to 8. I plug in T8 in both equation and put them equal to each other. So 30.6 negative 0.9 times to 8. I use this equation. And 1600 divided by 8 to power 2 plus K times to 8. I use this equation and replace 8. So let me type and bring it this side first of all, and I'm typing in calculator 30.6 minus 0.9 into 8 and minus 1600 divided by 64. My value is coming negative 8 over 5 equal to K times to 8. 8 will cancel out, it will go there, and I get negative 105. So you write negative 105 or k value negative 0.2, both are correct. Okay, both are correct. Okay, now k value we have it. And now I want to find out the what time is ending. So stops at what time? Okay, for that reason, I plug in velocity 0, last velocity. So 1600 over tide to t power 2 and the negative 1 over 5 t is equals to 0. This value, I'm copying it here. Now this will go there. So 1600 over t to power 2 equal to 1 over 5t. Cross multiply, so 1600 times to 5. I get as 8,000. And t cube multiply there, but got a t cube. And cube root will give you 20 seconds. It means 100% confirm that this starting from T8 and ending at 20. So stopping at 20. Now he's asking distance. You know, for your knowledge, we have 3 levels. First is displacement. Second level is velocity. Third level is acceleration. If I differentiate, I get velocity. If I differentiate once again, I'll get acceleration. But if I want to come down, I will do integration. If I want to come down from velocity to displacement, integration. So I am on velocity level and I need displacement. So I will do integration. So all 3 equations I will integrate. But problem is only one we want to know, because basically, you know, students, if something above or below, above is positive answer, below is negative. Positive means going away. Let's say it is 20 meters. So these are 20 meters and this, let's say 10 meters, or 20 going 20 backwards. So going 20 backward 20. So we get a 0 answer because it gives you negative answer. So net answer, if you integrate from here to there, for example, it will give you 0 answer, but 0 answer is not possible. So that is why diagram is very, very important to know. Okay, look at now. Just sake of your knowledge, I just add few things. Whenever t positive, we have this kind of line. When we have a t negative, we have this kind of line. When we have a t squared positive, we have this kind of parabolic curve. When we have t squared negative, we have this kind of parabolic curve. T cube Cummings, we have this kind of curve. And t cube negative, we have this. I think you got my point. So if you look at carefully, what is here t square and positive t square? It means we have this kind of curve, okay? So, okay, and then this negative t, you see negative t. So we have this kind of thing. And then we have a third equation, okay? This we can understand even. Okay, I just show you, although this diagram is not important to show the examiner, just for your understanding. And or you can put different values of in calculator. When I plug in 0, I get a 0. If I plug in some other numbers, it will increase. So it means we have this part of curve. You ask why, sir? Because it's starting from rest. You see this part of curve. So at 2, we reach here. At 2, okay? Although no need to show the values, it's just for your understanding. And now negative, and you know it. This line is coming. So it is coming somehow like this. Okay, and this is a 2 to 1 minute, 2 to 8. It is 2 to 8. Now 8 to 20. 20 is here somewhere. And if you plug in some numbers, like I plug in 9 here, 10 here, 12, and 20, so you will just get it, and I know it very well. So graph is coming this way, this way, this way, and it will not go down. It will be here. So we have 3 categories. So as a teacher, I suggest you, whenever he asks you distance traveled, so please sketch. Okay, sometime if the curve goes below x-axis, so this creates a trouble. So that is why as a teacher, I suggest you, and so that is why it is very important. We have 3 distances, D1, D2, and D3. And limits are very clear. I'm finding total distance traveled is how to find. First is 0 to 2. plus 2 to 8 plus 3 to 8 till 20. So we have 3. First equation is where? First equation is 7.2 t square. 7.2 t square dt. Second equation is what? Okay, let me write again. I have to come and go again and again. So 1600 over t square and negative 105 t. Okay. So students, what I will do, I will copy this upper part here. And this part I'll copy here. And here I must write dt. Here I must write dt. Now let's proceed. This is final form. No, nothing to change here. Here 2 to 8. Here no problem. But here I have to reshape. So 1600 times t to the power negative 2. Negative of 105 and t as it is. If you want to save your time, you can do it even here, the same thing. Anyway, let's start. Increase the power by 1 and divide by same. So 3 by 3. In 30.6 and one variable will come t. You know, whenever you integrate constant, only in case of dx, x come. In case of dy, y come. In this case of dt, t comes. Increase the power by 1 and divide by same. Okay, here if I increase the power, I show you, save my time. Increase, I got negative 1 by negative 1 or negative 1600 over t because power goes down positive. So I'm writing directly 1600 over t and negative is definitely there. And increase the power 2 by 2, 2 5s are 10. So I can say t squared by 10. Okay, students, now I'm going to plug in the values and get the answer. And I believe you got a point up till here very well. Okay. If you plug in 7.2 into 8 and divided by 3. So this is coming with us 19.2. 19.2, or I can say here, this is first answer 96 over 5. First answer. Here, if I 30.6 into 8 minus 0.9 times 264 divided by 2, I get 216 minus. So 30.6 into 2 minus 0.9 into 4 divided by 2. I get 297 over 5. So same story here. Minus 1600 divided by 20 and minus 400 divided by 10. Our first answer is coming negative 120 minus. So negative 1600 divided by 8, negative 64 divided by 10. I get negative 1032 over 5. Now, student, 96 over 5 is done. 216 minus 297 divided by 5, I get a 783 over 5. I think this is clear. Okay. And the last part, negative 120 plus 1032 divided by 5. I get it here. There's a plus sign. 432 over 5. So I think this part is clear. And if you add 96 over 5, 96 divided by 5 plus 783 divided by 5 and 432 divided by 5. So answer is coming finally with me. Distance total traveled is 262.2 meters. And I believe the point is very clear and we have done it. Okay. And the paper is completely over. I believe you understood the whole story and the whole paper. So best of luck for exam and best remedy in case of mistakes you done. So please redo those questions. Without redoing, there's no improvement will not come. And best of luck for exams. Assalamu alaikum wa rahmatullahi wa barakatuh.